So now you want to know, so if we're talking about describing how the original function changes with the first derivative, or like talking about the slope of the original function with the first derivative, think about the second derivative as talking about how the slope changes, or talking about, I guess think about it as the slope of the slope, right? So if you're looking at the first derivative, it's the rate of change of the original function. If you're talking about the second derivative, it's the rate of change of the derivative function. So if you took the derivative and then graphed it, and then look at the slope of the graph of the derivative, that's what the second derivative is. So what does it tell you? It tells you where the original function is concave up or concave down, and it tells you where the function's concavity changes. So that's going to be called an inflection point. So these are the two buzzwords to think about when you're taking a test. So if you want to talk, okay, so we're going to talk about concavity a little bit more conceptually. So the way I learned it is concave up is like a cup and concave down is like a frown. So anytime the function looks like a bowl or half a bowl or anything like that, or a cup, I should have probably said, that's going to be concave up. Anytime it looks like a frown or half a frown, it's concave down. So you can tell visually looking at it that way. So I kind of drew this goofy ass graph. And what we're going to do is talk about where the inflection points are. So that's going to be every point where it looks like it changes, whether it's up or down. And then concave up means anywhere that it's pink, you can kind of look at it and see that it's either a cup or half a cup or a part of a cup, something like that. And then concave down is everywhere where it's green. Okay? So pause it, look at it, see if you can like visualize it yourself, justify why each section is each section. And then sometimes it's easier to find where, visually it's easier to find where it's up and down and then find the inflection points. Calculation-wise, it's easier to find inflection points first and then go from there. So if you're talking about zones of concavity, admittedly it's not as intuitive to describe as the first derivative, but the process is the same, and that gets proven in the applications review video. So the steps are to calculate the second derivative. So you're given a function and take the derivative of that function twice. Cake. Then you're going to set the second derivative equal to 0, and that value, or the values you get from that calculation, or the solutions to that, are going to be called the inflection points. So that's going to be every point where it switches concavity. And then using the number line technique that, again, we go over definitely in lecture and most definitely in the applications review video, you're going to find the behavior on either side of the inflection points. And you do that by arbitrarily picking a value that fits into that range that you're looking at. And if that value comes out positive after plugging it into the second derivative, that means it's concave up. And if that value comes out negative after plugging it into the second derivative, that means it's concave down. So that's concavity a little bit. And I believe that is all that I have for this video.